this video, I'm going to be discussing and modeling for you some of our basic concepts with fractions. So let's first get a common understanding of what fractions are. Fractions are when a whole is divided or partitioned into equal parts. So this is a very important concept here. It's kind of the foundational skill of fractions, is that there's equal parts coming from the whole. So here I have an example of fourths, 4 equal parts. Here I have 4 parts, but they're not equal, so it's not fourths. Okay, so see the difference there. And so, we want to do our best when we're drawing fractions to show the equal parts, because later on it will help when we are, putting fractions side by side and comparing them. The better our drawings are, the more that our visual is going to match whether a fraction is greater or less. The fractional units that we will be focusing on in 3rd grade are halves, fourths, and eighths, and then thirds and sixths. And the reason that I wrote them this way is because halves, fourths, and eighths work really well together when we are drawing fractions and comparing fractions. And then thirds and sixths work really well together when we're trying to find equivalent fractions and drawing them as well. And you'll see later when I use that strategy here. So let's do a little bit of recognizing fractions and writing them in their numerical form, and then we'll do a little bit of practice with drawing them. So here I have this circle. Fractions can be partitioned from circles or rectangles, either way. So here I have my circle, and I notice that there are 4 parts to my circle here. Yes, some of them are black and some of them are white, but I have 4 total parts. So this fractional unit is fourths because there are 4 equal parts. So now I can look at this fraction at the shaded in part or the not shaded in part. They represent 2 different fractions. So when I look at my shaded part, I see that one of the 4 parts is shaded. So I'm going to write this in a numerical form as 1/4 or 1/4 or 1 of the 4. So here is my numerator. Numerator is on the top. The numerator represents the number that the part of the fraction that I'm focused on. And here I'm focused on the shaded in section. The denominator is 4, and that represents how many total parts there are. So again, I could think of it as one of the 4 parts is shaded. Now I could also look at this as how much is not shaded. Well, here I have 1/4, 1/4, and 1/4. Oh, I have 3 of the 4 parts is not shaded. So 3/4. The 3 is I'm focusing on the not shaded, and there are 3 parts of them. And the denominator here, my 4, is how many total parts there are, which is 4 parts. So 3 of the 4 is not shaded, 1 of the 4 is shaded. If we look down here at this drawing here in a rectangle, well, let me see how many parts there are. 1, 2, 3, 4, 5, 6. So 6 parts is the fractional unit of sixths. So I know that that's going to be my denominator no matter what, because the denominator tells us how many total parts there are. Now, if I'm looking at how much of my whole is shaded, well, I have 1, 2, 3, 4. 4 of the 6 pieces are shaded, and then 1, 2. 2 of the 6 is not shaded. So 4 sixths is shaded, 2 sixths is not shaded. So keep in mind what the numerator and denominator are telling us. The numerator is what part of the fraction we're looking at. So if I'm doing pizza, how many slices do have anchovies on them? And then the denominator is the total number of pieces, whether that has anchovies or not, whether it's black or white, whether it's shaded or not shaded. It's the total amount of pieces or parts. All right, so this is kind of recognizing and representing them in a numerical form. I'm going to show you a little bit about drawing them. So here I want to show 2/3. Okay, so I know that I need to break apart my circle or my rectangle into thirds. So I could do a circle or I could do a rectangle. So if I do a circle, I like to kind of think about 12 o'clock, 8 o'clock, and 4 o'clock, just so that I can do my best to make 3 equal parts. Is it going to be perfect? No, but I do need to put in some effort. Here I'm going to make thirds here. So I made my 3 parts. So that's my denominator is telling me 3 equal parts, 3 equal parts. My numerator, though, is telling me that 2 of the parts need to be shaded in, or 2 of the parts need to be similar in some way. So if this was a pizza, 2 of the 3 slices might have anchovies and the rest didn't. Or if this was a pan of brownies, 2 of the 3 parts might have nuts and the other wouldn't. So I'm going to shade in 2 of the 3. So 2/3. Here I'm going to shade in 2 of the 3. Now I do want to show you very quickly that this is also 2/3. These show the exact same fraction of 2/3. However, when we get later on into 3rd grade, we will want to represent it a little bit more like this because it's going to line up a little bit better with the other fractions that might be near it. And so you'll see that later on in 3rd grade. 6/8. So the denominator here is telling me I need 8 pieces. I need 8 equal pieces in my circle here, or 8 equal pieces in my rectangle. Now, 8s here, it's a lot of little parts. So what I tell the 3rd graders is back up a little bit and use other fractional units that work well with 8s. So I'm going to start with halves, and then I'm going to make that into 4ths, and then I'm going to split it into 8ths. So if I kind of do a top to bottom, side to side, and then an X through it, it's going to be my best bet that I'm going to get 8 equal pieces. Whereas if I start here and start trying to make 8, I might end up with something really tiny or really large, and then that wouldn't represent 8s. It would represent 8 pieces, but not 8 equal pieces. All right, so here I have my 8ths. Oh, let me make my halves, and then my 4ths, and then the best I can to get 8ths. So there are my 8ths. Now, my numerator here is telling me I need to have 6 of them be similar in some way. Well, I could do 6 of the 8 are white or 6 of the 8 are shaded. It does not matter. So for this one, I'm going to keep 6 of them white. So 1, 2, 3, 4, 5, 6. So I'm going to keep these 6 white, and then I'm going to shade in these. So here, 6/8 is actually representing the non-shaded part. Most of the time you're going to see 6/8 representing a shaded piece, so you have to be careful what the question's asking. So 6/8 is not shaded. Here I'll do 6/8 is shaded. So here you got to be careful. My shaded part here is equal to my non-shaded part here. But you will be asked questions about both, whether it's shaded or non-shaded. So you got to think about what the question's asking so that you can write it numerically or represent it in a drawing in the way that it matches. One other thing I want to point out is here, let's say that I have a whole and I break it into halves. So I have 2 equal parts. And then I go and I break it into 4ths. 3rd graders need to start recognizing that if my whole stays the same and I start adding more and I start breaking it into more pieces, yes, I have 4 instead of 2, but the pieces are now getting smaller. So now if I'm going to take my 4ths and I now want 8 equal pieces, all right, so I'm going to have more pieces, but if you notice, they now got smaller. So that's also a key concept for later when we are comparing fractions, finding equivalent fractions and things like that. So the more pieces you make, yes, you have more of them, but they are getting smaller and smaller and smaller. So keep these ideas in mind when you're doing your fraction work, whether it's remembering that it's equal parts or that the numerator tells us how many pieces we're focusing on. The denominator is the total number of pieces, and then kind of work with those halves, 4ths, and 8ths, and those 3rds and 6ths that work well together.